Alright, this is 7.2, confidence intervals when sigma is unknown. This is a lecture vid. Here we go. So, when sigma is unknown, we're going to use a t distribution as opposed to a z distribution. Alright, so a t distribution is short for a student t distribution. And if you want to, you can look up Gossett and find out the story behind it. It involves Guinness beer and where he was working at the time and secrecy issues. Now, the thing to understand about a student t distribution, or just a t distribution, is that it's a family of curves. In other words, I'm going to draw a new line here, and you see how this line hits the same point right here, but it doesn't get quite as high? All of these curves that are drawn that look normally distributed are, guess what? They're not normally distributed. Alright? It's bell-shaped in that it's symmetric. It has a hump in it, but it's not normally distributed. Right? Depending on your degrees of freedom, you're going to have a different curve. So when we're using a t distribution, you need more information than just your mu and your sigma. You need your mu, your sigma, and you need to tell the calculator which family of curve, which individual member you have. So what your degrees of freedom are. Normally they just ask for n is. Now for everything we're going to do for this chapter and the next chapter, the degrees of freedom, abbreviated d dot f dot, or just df, is equal to n minus 1. So your sample size minus 1. Alright? Now, depending on what the degrees of freedom are, the smaller the number, the flatter it would be. The higher number, the more peaked it is. And as n goes to infinity, your t distribution would go to become a z distribution. That's why when we look at things later on, and I have my next video to explain it, if your sample size is greater than 30, and if you remember the central limit theorem, as your sample size increases, it becomes more and more normally distributed. Before it's normally distributed, it's a t distribution. So 30 is kind of our cutoff where we say, you know what, it's precise enough, we're just going to use the z values, and the precision is as close as we need it to be. Otherwise, and it's lower than 30, we always have to use a t distribution. And that's part of the flow chart I will do in the next video. So what we need to get out of this is, when you don't know sigma, you're going to be using a t distribution. A t distribution will behave exactly like a z distribution. We'll do exactly the same stuff. In the video after the next one, I'll do a problem and we'll use the calculator. But when you do a t distribution as opposed to a z distribution, you need to keep track of what n is, because you have to tell it, and I'm circling this here, what the degrees of freedom are, or what n is. Remember, the degrees of freedom are just your sample size minus 1. For now. Later on, that might change.